In this video we deal further Dirichlet equation and several applications of infinitesimal analysis. We show the new possible mathematical connection with the MRB constant, some sector of number theory, various Hertz equation and string theory. In the picture, Peter Gustav Lejeune Dirichlet and the landscape of Vesuvius, Naples. Now, from this work, we analyze the following equation. We obtain, this is the input, and this is the study of the equation, alternate forms, real solution, integer solution, and so on. We consider also this expression that we obtain from the considering the previous equation less 0. This is the input, this is the result. The program, the mathematical program Wolfram Alpha consider the geometric figure the infinite paraboloid. Also here we see the alternate form, the real root, the roots, and the study of the expression, and so on. Now, from this equation, we obtain, this is the initial data, this result. We see the root plot, a figure that can be related to an open string. Also here we note the alternate forms, the solution, sum of roots, the product of roots. Now, from the previous exact result, that is, okay, for omega equal to root of 2, we obtain this expression and this result. Okay. We have the three-dimensional plot, a figure that can be related to a de Bruijn instanton. The first, okay. After we have also here the alternate forms, real roots, polynomial discriminant, and so on. From the result that we have previously obtained, for x equal to 2 and epsilon equal to 0, this value, this for x and epsilon equal to these values, we have the following expression that is and then choose this result. Okay. From which, after some calculation, we obtain this expression. we note that this value is equal to the value of the following Roger-Ramanujan continuous fraction. Okay? The result of this expression, that is equal to is equal to a result that is a very good approximation to the value of the golden ratio. Now, from this other work of Dirichlet, we analyze this expression, that is and okay. This is the result. Also here, the study of the function, series, derivative, indefinite integral, alternative representation, and so on. Further the previous expression, we analyze also this other expression, that is okay, and the result is also here the study of the function, alternate form, root, and so on. Okay. Now, from the algebraic sum of the two results, the first and the second, we obtain the following expression, that is okay. Also here the alternate form and the study of the function, practically series expansion at d equal to 0, series expansion at d equal to infinity, and so on. From the above alternate form, following alternate form, that is the following, we obtain for d equal to 4, rho equal to 8, sigma equal to 16, t equal to 32, u equal to 64, we have the following expression and this result. Also here the study of the function, the series representation, integral representation. From the last results, we note that after some calculation, this is the result, okay. After some calculation, we obtain this other result, that gives a number, a value that is a very good approximation, also here, to the value of the golden ratio. Also here the study of the function, alternate forms. Furthermore, from the previous expression, we obtain also, this is the expression, this other exact result. That is, very near to the mass of candidate gluable. That is a scalar meson, the mass of a scalar meson. Also here the study of the function, alternate form. Furthermore, from this other calculation, we obtain this other value. This other value. Practically, we obtain 4096, which multiplied by 2 gives 8192. That is the gauge group SO 8192. That is fundamental in the theory that regarding the open bosonic strings. Also here we have the study of the function, then the alternate forms, expanded forms. Furthermore, performing this following calculation from the previous expression, we obtain this result. That is the value very near to the value of zeta 2. That is equal to pi Greco squared divided by 6. Also here the alternate forms. Now, from this other work of Dirichlet, we have the following integral equation. Now, we calculate the first integral and after the second integral, that is to the right hand side of the expression. This is the indefinite integral, alternate forms, and so on. This is the second integral. Also here the alternate forms, expanded forms, and so on. Now, from the algebraic sum of the two integral results, we obtain this alternate form, and for f equal to 1, n equal to 4, and kappa equal to 8, we obtain this following expression. That and then the exact results. That is approximately 1 divided square root of 2. Also here the study of the function. as we see. From which, practically from the previous expression, after some calculation, we obtain, inverting the previous value, this expression and this exact result. A result that is very near to this is the study of the function. It's a very long, a beautiful mathematics. And from the previous expression, after some calculation, we obtain this exact result. Practically a value very near to 4096. That multiplied by 2 gave 8192. That is a gauge group SO 8192, and this is fundamental in the theory regarding the open bosonic string. Again, from this expression we obtain, after some calculation, these other results, practically 1729, a value very near to 1729. Is the so-called Hardy-Ramanujan number and is very close to the mass of the candidate gluable F0 1710 scalar meson. Again, from this expression, after some calculation, we obtain also this result. This result that is a number very near to zeta 2, that is equal to pi greco squared divided by 6. That we hypothesize that can be the trace of the instantaneous shape. From this other integral expression, we obtain from after the following calculation and study of the function this alternate form. Okay. From the second integral of the above expression, we obtain the following alternate form. And the study of the function. Now, from the algebraic sum of the two integral results, we obtain this expression, that is, okay, also here the study of the function, choose the alternate forms, derivative, and so on. From the alternate form, that is for n equal to 4 and kappa equal to 8, we obtain this expression, okay, and the following exact result, that is equal to this value. Also here the study of the function, alternate forms, alternative representation, and so on. Also this expression is a very beautiful mathematics. Now, from the exact result, from the above exact result, okay, after some calculation, we obtain this result, this expression that gives this result. Practically, a result that is very near to 1729 as above. Furthermore, from the above expression, we obtain also, after some calculation, a result that is very near to zeta 2, that is equal to pi greco squared divided by 6, that we hypothesize is the trace of the instanton shape. Again, from the above expression, after some calculation, we obtain also a value very near to the 4096 as above. Now we have performed another calculation of the previous integral expression. This is the development from the two integral results, the first and the second. We obtain this expression, this is and this exact result. Okay. We note that the plots can be related to the D0 branch because are similar to points or particles. Also here we observed alternate forms, the series expansions, derivative, indefinite integral. Now, from the result of this expression, we obtain this alternate form. 1, 2, 3. And the study of the function. From the algebraic sum, from the algebraic sum of the first and this other expression that we have previously obtained, we have that for f equal to 1, n equal to 4, and kappa equal to 8, we obtain these other expressions and finally the exact result, that is very near to 1 divided by square root of 2. Also here the study of the function, addition formulas, alternative representation, and so on. As from the above result, that is this expression, after some calculation as before, we obtain this result, practically a number very near to 4096, that multiplied by 2 gave 8192. That is the gauge group SO 8192, fundamental for the open bosonic strings. Also here the study of the function, alternate form, and as before, also here we obtained also from the previous expression and after some calculation a result very near to 1729, and again a result very near to zeta 2, that is equal to pi greco squared divided by 6. That is the trace of this Anton shape. Now, in this work, we have analyzed also some equation of Heinrich Hertz. Now, we have the following equation. Okay. This is the equivalent expression. This is the input, and also here alternate forms, expanded forms, and we consider u equal to x, and after some calculation we obtain these alternate forms 1, 2, 3. We consider the above series expansion, that is, okay, we consider this expansion as follows. Okay, the result is the following. This is choose the alternate forms, derivative. Now for rho equal to 8 and zeta equal to 16, after some calculation we obtain from the above result, that is the following. We obtain this exact result, that is this value. From which, after some calculation, we obtain a value very near to the speed of light. Also here the study of the function, alternative representation, series representation, and so on. But From the previous expression, after some calculation, we obtain also this other expression that is equal to a result that is a very good approximation to the value of the golden ratio. Also here the study of the function. Now we have the following equation. Okay. We consider the first, that is this equation. That is the input, that is the result. Okay. From the result we obtain we see the three-dimensional plots, the real parts and the imaginary part, that picture that can be refigured, that can be related to the de Bruijn instanton. Okay. Also here the study of the function. Now, from the first equation, we take, okay, that is this expression, and obtain this result. Also here the study of the function. Now we analyze the second equation. That is this expression and this expression. This is the exact result. Also here the study of the function. In conclusion, we analyze also this third equation. This is expression. This is the exact result. Okay. Also here the study of the function. Now, from the algebraic sum of the three results, we obtain this expression. That is the following. And the following exact result. Okay. From the exact result, we obtain for n equal to 60, m equal to 32, n equal to 64, and mu equal to 8, and sigma equal to 4, this expression. And the following exact result. Also here the study of the function, as we can see, from which the previous expression that we have, from which we have obtained the result, after some calculation we obtain this is the expression. This is the exact result. a value that is very near to the 4096 as above. Also here alternative forms, alternative representation, and so on. Again, from the above expression we obtain also a number very near to 1729, and after some calculation also a value very near to zeta 2, that is pi greco squared divided by 6, that is the trace of the instanton shape. Now we have the following three equations that we have the following expressions. One, this is the result and the study of the function. Two, that is the result and the study of the function. And three, this expression, this is the result that is equal to this value and the study of the function. Dividing the previous exact result by the algebraic sum of the above results, we obtain the following expression. That is, and we obtain the following exact result. That is this value. Also here the study of the function, alternative representation, series representation, and so on. We obtain also the following expression and the following exact result. Practically a value very near to pi multiplied by 4. Also here the study of the function. From the previous expression, after some calculation, we obtain also the following exact result. That is a value very near to zeta 2, that is equal to pi greco squared divided by 6. That is the trace of the instanton shape. Also here the study of the function, the alternate form, expanded form. Okay. Also in this work we can observe that the so-called recurring numbers are 1729, 4096, zeta 2, and pi, given by the 15th root of 1729. That is the so-called Hardy-Ramanujan number, and is very close to the mass of the candidate gluable F0 1710 scalar meson. 4096, which multiplied by 2 gives 8192. That is fundamental for the theory regarding the open bosonic strings. Furthermore, zeta 2 and the golden ratio, we hypothesize that they can be connected to the geometric shapes, variety or Calabi-Yau space, that are formed by the compactification by the winding of the 6 or 7 additional dimensions that contemplate both the string theory and the M theory. We believe in the possibility that the theory of numbers, especially the Ramanujan's mathematics, the Dirichlet mathematics, and the Hertz equations, especially Ramanujan, with this fundamental work, modular equation and approximation to Pi Greco, could lead in the not too distant future to the unification of fundamental physical interaction, at least from the point of purely mathematical. Thank you very much.